Okay, circles. All right, so let's talk about some circles. Okay, there's a couple formulas that you absolutely will have to know. First of all, you know the equation of a circle. So that's going to be, and I'm just going to write it down again here. I'll erase it shortly. So it's x minus h squared plus y minus k squared equals r squared, where hk is the center of the circle and r represents the radius. Okay, so that's the equation of a circle. You got to know it. Another equation you need to know is midpoint, and if you make sure you understand these, then this circle thing's gonna be a lot easier for you. So x1 plus x2 over 2, that's the x coordinate, and then y1 plus y2 over 2 gives me the y coordinate. That'd be the midpoint of a line. Okay, we did this last year, not this one. Distance formula. Okay, it gives me how far one point is from the other, or the endpoints, and that's going to be helpful. So d equals the square root of the difference in the x's squared plus the difference in the y's squared. So x2 minus x1 and y2 minus y1. And the last one that you'll need to know is point slope formula. Okay, so these three we did last year, but this one's new. So we have to kind of apply all these things together to make it work. So point slope formula is y minus y1, which equals the slope times the quantity of x minus x1. Okay, so this y1, x1, that's just that ordered pair, and you can just plug it in to find out what that is, and represents the slope. These four formulas you need to know off the top of your head for sure, because we need to apply these things differently. So you're talking about tangent lines, you're talking about endpoints. Hopefully this will be a little bit easier for you. So I'm going to go ahead and erase that. And I'm going to go off camera a little bit because I want to make sure you know that there's a really, really awesome graphing site. It's called Desmos.com. We used it last year. This will really, really help visualize the whole circle thing because you can put the equation of a circle in and it will actually show up, and I'm going to show you one or two of those today. So here is page 3 of what you were talking about. I'm working on the second half of page 1 and page 2, just so you know, and I'll get that to you a little bit later, but I wanted to do this right now for you so you had something concrete to work with. And you might be able to derive some things for page 2 and page 1, off camera, on camera. Okay. All right. The first one, I know this is hard to see, but you wrote it. So the first one is, if I have endpoints of a diameter, I need to find the equation of a circle. Okay, and you have your work totally correct here, but I want to make sure you understand what you did. Basically, if I have endpoints of the diameter, well, the diameter is, right through the circle. So I'm eventually going to go right through the center of the circle. So it'll help me find the point of the center. But if I have my points in the diameter, so on Desmos, I'm just going to go ahead and graph that. The first point is 4, 2. So 4, 2. And the second point is -6, -10. So -6 and -10 is going to be down here. Now, this represents the diameter. So the center of the circle has got to be in the middle. That's why you have to use the midpoint formula here. And when I put these two coordinates into the midpoint formula, you get a midpoint of -1, -4. So the center of the circle is -1, -4. Now, when you have that, that's h and k, right? So that's going to be a lot easier to start, at least fundamentally, to start your equation of a circle. So your equation of the circle is going to be x plus 1 squared plus y plus 4 squared equals some radius. So we need to find the radius. But you already know the radius because you have the center point and you know two endpoints of the circle. So the circle has to go around that point and around that point. Now that you know that, you can find the radius by using the distance formula. So the distance formula is going to give you actually these 2 points here, right? So I'm going to use -1, -4, and it doesn't matter which one of these you use. Who cares, right? Because it's still going to work out nicely for you. So let's just go ahead and use that one because it's a little bit nicer of a number. So this is 4, 2. Now let's put this into the distance formula and see what we've got. So x1, y1, x2, y2. So it doesn't matter the order. 4 minus a -1, so 4 plus 1 squared plus 2 plus 4 squared. So this is going to be 5 squared plus 6 squared. So this is 25 plus 36. So what I have is the square root of 61, because what you had, right? I don't know what that is. I don't know what the 2's out there. But this is the square root of 61. But remember, it's it's radius squared. Hopefully you can see that. Well, you can't, sorry. But it's radius squared, so if I'm squaring this, the square of a square root is just the number underneath. So this is just going to be 61. Now I'm going to plug this formula, this into the calculator, and you're going to, into Desmos, and you're going to see how nicely this adds up. Hopefully it's going to actually fit perfectly on the screen. So I'm going to go off screen for a second, plug that in, and hopefully you'll be able to see it. So hang tight. Okay, so we've got it, right? Center of the circle, it looks like the center of the circle. Check it out. Our points are exactly, well, you can't see that because the phone's in the way. Sorry, this is my makeshift way of doing this. But the points add up exactly on the endpoints of the circle. I just plugged in the center, the equation of the circle, and it came up perfectly for me. So Desmos is going to be really, really, really helpful when you're starting to study and when you're starting to do other things. Okay? Awesome. Let's go on to that second problem that you had, and we'll see what we can work out. Actually, the second problem is pretty easy. It's a lot easier than you think it is. So the second problem here, if you're given the center of the circle, which makes it a lot easier, which was 2, 3, and it's tangent to the x-axis. So that means that the x-axis, right, the x-axis only touches the circle in one point, one place. And you know by your drawing, which is actually pretty good, that it's going to be tangent at the point 2, 0. So let me erase this, right, because it's a new problem now. And let's see what we can work out. I'm going to move this down a little. Let me get rid of that. Okay, so I know the center is 3, 2. I'm sorry, 2, 3. So 2, 3. There's the center of the circle. Now, it's tangent to the x-axis. Well, the x-axis is the line y = 0. So it's tangent to this line here, which means the circle can only touch one spot there. Because we're talking about horizontal and vertical lines, I don't need to use a distance formula. I don't need to use midpoint. Midpoint's only if you don't know the center. We do know the center, though, so I don't have to use anything except finding the radius, right? Because the radius is the only thing that's missing. Because the equation of this circle so far is x minus 2 squared plus y minus 3 squared equals some radius. But we actually going to know the radius because all I need to do is count. See, the distance formula is for lines like that because I can't count that line. Like I can't just go 1, 2, 3, 4. But I can count a line like that. Or more specifically in this problem, I can count the distance of that line. So if that's from 0 to 3, the radius is 3, which means that the radius here is going to be 9, or the r squared is going to be 9. Now, let's go ahead and plug this in, and let's make sure that it works. So Desmos is a really, really awesome tool. Use it. It's awesome. So I'm going to plug this into there. Hopefully it'll work out nicely. And it will. X minus 2 squared plus y minus 3 squared equals 9. Perfection. And you see how it's tangent to the x-axis. The center is right here. Voila. Okay, awesome. Let's go to that next one. That next one, like I told you in the email, it's a bit of a doozy. Okay. You need a couple of things in order to solve this one because it doesn't give you a whole lot of information. And I know this video is long, so hopefully this is going to work out for you. So I have the center of the circle. Awesome. It doesn't really give me a whole lot else, though, because it gives me a line that's tangent, which is y = 2/3 x plus 4. You have the right idea. You need to find a perpendicular bisector. And we actually did a lot of this last year, but when we try to apply it to circles, it becomes a nightmare. So we first have to plot the line y = 2/3 x plus 4, because that's the tangent line. And since I already know the center, I need to find that perpendicular bisector. So I'm going to go off screen and plug those two things in so we can have an idea of what we're doing here. So y = 2/3 x plus 4. Okay. And I believe that the center of the circle was 1, -4. All right. Center of the circle is 1, -4. So I need a line that's going to be perpendicular because we're trying to find, see, remember this, we have the formula for the circle, so it's 1, -4, that's the center. So I can pretty much plug in everything except for the radius. I don't have that yet, which we're going to find out very, very shortly. So this is x minus 1 squared plus y plus 4 squared equals some r squared. Now, if the circle is tangent, if this line is tangent to the circle, that means this line only touches the circle in one spot. So it's going to be somewhere in this area, right, where it's going to touch. If I find a perpendicular line from this line going through that point, now I'm going to be really, really careful to that so I can find out what the radius is, because that's the only thing that's missing to find this circle. That's it. So I'm going to use the point slope formula because I have a point and I actually know the slope of the perpendicular line. Remember last year when we talked about perpendicular line slopes? The slope of this line is 2/3. So a line that's perpendicular to it has to be the negative reciprocal, right? We talked about that last year. So if this slope is 2/3, that means that the slope of the perpendicular line needs to be -3/2 because it's flip fraction with a negative in front. So I have the slope, right? So m is going to be this. And I have a point because the line has to go through that point. So the point is 1, -4. Now I can use point slope, right? Point slope. So point slope formula is y minus y1 equals m times the quantity x minus x1. Just plug stuff in. Y plus 4 equals -3/2 x minus 1. Solve here, so y plus 4, hopefully you can still see it, equals -3/2 x plus 3/2 minus 4 minus 4. This is actually going to be y equals -3/2 x minus, I believe this is 5/2, right? 1/1. Yeah, okay. This is the line that's perpendicular to that one. So I'm going to plug this line into Desmos and you're going to see what happens. It's going to go right through the center of the circle because we made it do that. So y equals -3/2 x minus 5/2. Check it out. See? Here's my perpendicular line. It goes right through the center of the circle. And take a look. Now I've got 2 points. This point is where the circle touches this line because now we pinpointed it exactly. So now that I have these 2 points, this here represents the radius of that circle. So now that I have the radius, now I can use the distance formula to find the distance between these 2 points. And this will be the last thing now because we're already over about 12 minutes. So this point here is -3, 2. So I have -3, 2, and I'm going to use the center as the other distance point, 1, -4. Distance formula. So x2 minus x1, so 1 plus 3 squared, plus -4 minus 2, which is just going to be, it's -6 squared, so it's just going to be 6 squared, right? So this is going to be 4 squared plus 6 squared. So 16 plus 36. It's the distance between the center of the circle and this point of tangency is the square root of 52, but remember we're squaring it, right? So it gets rid of this. The answer is this. Now I'm going to plug this in and you're going to see exactly where this circle ends and meets so you can check your work. Hopefully it's going to be right and then we'll stop there and I'll get you some more information later on today so you can be ready. But I'm going to plug the equation of the circle in. X minus 1 squared plus y plus 4 squared equals, and we've got 52. Keep your fingers crossed. Oh, I erased the center of the circle. Well, that's the center of the circle, right? Check it out. Point of tangency right here. The circle touches the tangent line only once. We've got our circle perfectly. Here is the equation of the circle. Bam, done. That's page 3 out of the way. Gonna work on page 2 for you. I just want to make sure that I can give it to you in a good manner. But check this out. It's good for you. Yeah, it's awesome. So let me know if you have any questions. See ya.